Hi students, we are starting quadratic equations of algebra. We know if we write 2x plus 3x plus 5, it is a polynomial in x. It is a polynomial in x. When you write 2x square plus 3x plus 5, this becomes quadratic polynomial. Quadratic polynomial. Secondly, if we equate this 2x square plus 3x plus 5 is equal to 0, or 2x square plus 3x plus say x square plus 3x plus 7 is equal to 0. These are quadratic equations. These are quadratic polynomial, and when you equate it with 0, it is called quadratic equation, where square is present. In childhood, we have studied expansion of brackets. X plus a, x plus b is equal to 0. Therefore, x into bracket x plus b and plus a into bracket x plus b is equal to 0. When you multiply these brackets, x square plus xb plus ax plus b ab is equal to 0. Therefore, x square plus a plus bx plus ab is equal to 0. This is a standard form of quadratic equation, and a and b are called its roots. Its roots. A and b are its roots. In any case, here should not be 0. The coefficient of term with x square should not be 0. Means if you put 0 here, the term x square will become 0 and the equation is not a quadratic equation. How to recognize quadratic equation? The highest degree must be 2. The highest degree must be 2, and the first term should not be 0. The first term should not be equal to 0. So this is the condition for quadratic equation recognition. This was opening the brackets. This year the standard form of quadratic equation is ax square plus bx plus c is equal to 0. Ax square plus bx plus c is equal to 0. A should not be equal to 0. Condition is a should not be equal to 0. Otherwise the equation collapse and the quadratic equation will be in vain. So remember, a should not be 0 in any case. This is the introduction of quadratic equation. Directly we are going to methods by which we can solve the quadratic equations. The way we solve linear equations, similarly we can solve the quadratic equations with different ways. One or two methods you might have learned in previous standards, that is splitting the middle term, that is called factorization also. We are going to start the same again in 10th as a revision. So let us see what is factorization. Factorization is a simple process in which an equation is given. This is called first term, this is called second term, and this is called constant term. First term, second term, and constant term. You have to split the middle term in such a way that the product must be the last term. The product must be the last term, and sum of those numbers must be the middle coefficient of middle term. The product of those numbers must be the last term. The product must be last term, and sum of those numbers must be the coefficient of middle term. So 3 and 2, the relation of 2, the products of 2. So 2 into 1, 2. But 2 plus 1, 3. These numbers are useful. This number is used in the equation by using the coefficient. So this 2, 2x, this one, 1x. So this has become, the equation has become two parts. Out of that, first part you consider, take out x common, you will get x plus 2 in the bracket. X plus 2 in the bracket. Secondly, in this 1 and 2, the smaller is 1 and 1 is common. So 1 has taken common, and in the bracket we got x plus 2. After that, these two terms are common, so it has taken out, and uniting these two terms we form the second bracket. Uniting the remaining term we form the second bracket. You have studied this in 9th standard. So we got two brackets. Equate them with zeros. When you x plus 2 is equal to 0 and x plus 1 is equal to 0, by transferring the numbers, we got x minus 2. X is equal to minus 2 and x is equal to minus 1. In linear equations, we were calling them as a solution set. Here, we will call them as a roots of the given equation. Roots are minus 2 and minus 1. So this is the method is called factorization method. Before that, in exercise number 2.1, they have given lot of practice to make you understand what are quadratic equation and how you will recognize them. So this is introduction part, exercise 2.1. We are going to start now. Question number 1 of exercise 2.1 is write any two quadratic equations. Write any two quadratic equations. So standard form of quadratic equation is ax square plus bx plus c. So we can write any number. You can write any number. So say 3x square plus 5, let it be 10x plus, take any number, 15 is equal to 0. This is the first equation which we have written as a quadratic equation. Let us check. 2 is the degree, passes. There is no any negative degree, passes. Value of a is not 0. Value of a is not 0. So this is a quadratic equation. This is a quadratic equation. This is a very simple. You can write second one. Say 7x square. Any square you can take. They are written 2. So 7x square is equal to say 81. Therefore 7x square minus 0x minus 81 is equal to 0. They had given, we have made an equation 7x square is equal to 81. So initially it may not be looking like a quadratic equation, but it will be. How? We have transferred that 81 this side will become minus 81, and one term, the second term is missing. Second term is missing. Instead of that we put plus 0x, plus 0x, missing term. Condition is the first term's coefficient should not be 0. The coefficient of first term should not be equal to 0. It is not 0. So this is a quadratic equation. Very simple. Write any two quadratic equations. You can use any numbers. The degree should not be negative and degree should not be more than 2 and less than 2. Degree should not be more than 2 and less than 2. That's enough. So two quadratic equations. Second question is, decide which of the following are quadratic equations. X square plus 5x minus 2. X square plus 5x minus 2 is equal to 0. This is in the form of this is in the form of ax square plus bx plus c. You will say here minus, that may be, the negative sign may be, but it is in the form of ax square plus bx plus c. So this is a quadratic equation. This is a quadratic equation. So value of a is equal to 1, value of b is equal to 5, and value of c is equal to minus 2. I am giving my little bit more knowledge in these examples, so it will be useful for next examples, coming examples. So this is very easy. The degree must be 2, not less than 2, not more than 2. No negative degrees must be there. And third, the coefficient of first term should not be equal to 0. So this is a quadratic equation. Second one is y square is equal to 5y minus 10. Y square is equal to 5y minus 10. Therefore, y square minus 5y plus 10 is equal to 0. This is a quadratic equation. This is a quadratic equation. Now let us see which are not quadratic equations. See, we got the idea. The degree must be 2, degree must not be negative, and the term, first term should not have the 0 as the coefficient. So let us see which are not quadratic equations and why. Let us see the equations. We are taking the third equation. It is y square plus 1 upon y is equal to 2. Y square plus 1 upon y is equal to 2. Let us check. In linear equations also we have studied the variable should not be in the denominator. We have to remove it. How we will remove it? By multiplying the same variable. So multiplying by 2. So 2y square plus multiplying by y. So y into y square plus y into 1 upon y is equal to 2 into y. To remove the variable in the denominator, we have multiplied the equation by y. These two cut, it will be y cube plus 1 is equal to 2y. Therefore, y cube minus 2y plus 1 is equal to 0. No. Why it is not a quadratic equation? The degree has changed to 3. The degree must not be more than 2 and less than 2. So this is the equation we got. It is not a quadratic equation. So you write there, the given equation is not a quadratic equation. Now I am taking the fourth example. X plus 1 upon x plus 1 upon x is equal to minus 2. Therefore, the rule is the coefficient should not be in the denominator. So, x into x plus x into 1 upon x is equal to minus 2 into x. Therefore, x square plus 1 is equal to minus 2x. Therefore, x square plus 2x plus 1 is equal to 0. You can check this equation will follow all the rules. The degree must be 2. Then there is no any negative index or negative degree. And first coefficient is not having 0 as its coefficient. So this is a quadratic equation. Next one is fifth one. When you solve two brackets, it gives us quadratic equation. So m plus 2 and m minus 5. Therefore, m into bracket m minus 5. The opening of bracket you have studied in the last lesson of 6th standard, opening the brackets. Plus 2 into bracket m minus 5 is equal to 0. Therefore, m square minus 5m, m square minus 5m plus 2m minus 10 is equal to 0. It is better to explain you must take care of sign. If positive, negative sign, if you are making any mistakes in that, your all efforts will be 0. Therefore, minus 5 plus 2. M square minus 5 plus 2, it is minus 3m minus 10 is equal to 0. So this equation is also following the rules of quadratic equations, and it is a quadratic equation. So final answer must be like this. M square minus 3m minus 10 is a quadratic equation. Very simple. Next one. It is m cube plus 3m square minus 2. M cube plus 3m square minus 2 is equal to 3m cube. Therefore, that 3m to the right hand side, it should be 0. So that 3m will come this side. 3m cube plus m cube plus 3m square minus 2. Therefore, minus 3 plus 1 minus 2m cube plus 3m square minus 2 is equal to 0. Now you tell me why it is not a quadratic equation, where it is failing. When the degree is 3, definitely it is not a quadratic equation. It is not a quadratic equation. Minus 3m cube plus 3m square minus 2 is not a quadratic equation, since degree is greater than 2. Degree is greater than 2. Very simple. If you use logic, you will get full marks of these examples, and definitely you will score. We are starting the question number 3. You can check there. Write the following quadratic equations in the form ax square plus bx plus c, and write the values of a, b, c for each equation. The first one is 2y is equal to 10 minus y square. 2y is equal to 10 minus y square. The given equation is 2y is equal to 10 minus y square. It is not in the standard form. The standard form is different. This is not in standard form. So standard form ax square plus bx plus c is equal to 0. So we have to make it in such a fashion that it should be in the standard form. So take out these all things here, or send this one. So y square minus becomes plus, minus 10 plus 2y is equal to 0, and the final step is this way: y square plus 2y minus 10 is equal to 0. In this step, it has come in the standard form, and you can now compare with ax square. therefore value of या फिर अगर just compare with ax square plus bx plus c is equal to 0, a 1, b 2 and c is equal to minus 10. Very mechanical thing. Transfer the things, change the sign, and you will get a quadratic equation in standard form. When you get a quadratic equation in standard form, compare with the standard form. A1, B it is plus 2 and C is minus 10. So these are the values of A, B and C. Next one is x minus 1 the whole square is equal to 2x plus 3. X minus 1 the whole square is equal to 2x plus 3. So let us see what happens. You all know this is an identity. So expansion of this x square minus 1 into x, 2x plus 1, ax square plus 2 ax square plus 2ab plus b square is equal to 2x plus 3. Therefore this will come this side. So x square minus 2x plus 1 minus 3 is equal to 0. Therefore x square minus 4x minus 2 is equal to 0. This is the standard form of that given equation. Now compare with ax square plus bx plus c is equal to 0. A becomes 1, b is equal to minus 4 and c is equal to minus 2. You must remember the identity a minus b the whole square. Ax square plus 2ab minus ax square minus 2ab plus b square. You must know the logics to solve the algebraic sums very nicely. So let us see the next one. So we are in the same example of exercise 2.1. The example number 3. They have given x square plus 5x is equal to minus into bracket 3 minus x. Very simple. These two will remain same and this bracket will get open. So minus into 3 minus 3, minus into minus plus x. Transfer these all things to left hand side. So x square plus 5x minus 3 becomes plus 3 and plus x becomes minus x. So x square 5x minus x 4x and plus 3. So this is standard form ax square plus bx plus c. When we compare with the standard form, you will get a 1, b 4 and c is 3. Next one is 3m square is equal to 2m square minus 9. 3m square is equal to 2m square minus 9. Bring these all things to right hand side, left hand side. When you bring this 2m square to this side, it will become minus 2m square and minus 9 will become plus 9. So 3 minus 2 is m square and plus 9 will be becoming minus plus 9. So m square plus 9 is a quadratic equation. But one term is missing, the middle term. We have to bring it. How? Put 0 m. Put 0 m. It will become a 0 must not be with the square term. 0 with other terms can be allowed. So the middle term has got 0. M square plus 0m plus 9 is equal to 0. When you compare this with ax square plus bx plus c is equal to 0, you will get a is 1, b is 0 and c is plus 9. Plus 9. So these are the things. And next one is fifth example. Just they have reshuffled the things and given to you to make it ax square plus bx plus c is equal to 0 in this form. So p into bracket 3 plus 6p is equal to minus 5. Opening the bracket, 3 into p, 3p, p into 6p, 6p square and minus 5. So rearranging 6p square plus 3p and this minus p becomes plus p. So the equation will be 6p square plus 3p plus 5 is equal to 0. Compare with the standard ax square plus bx plus c. You will get a is 6, b is 3 and c is 5. So this is the very simple types. These are the very simple types of examples. You may score full marks in this if you keep your mind calm while changing the sign. This is the last example of the same sub-example. They have given us x square minus 9 is equal to 13. X square is there, so possibilities are there. So transfer this 13 to this side, you will get minus 13. And then you will get x square minus 22 is equal to 0. The missing term is important. The middle term is missing. So we put here 0x. We put 0x. Now it is a standard form. X square plus 0x minus 22 is equal to 0. Compare with ax square plus bx plus c. Compare with ax square plus bx plus c. You will get a 1, b 0 and c minus 22. C is minus 22. Now we are studying fourth example of exercise same. Determine whether the values given against each of the quadratic equation are roots of the quadratic equation or not. They will give you the quadratic equation and they will give you some numbers. They will give you quadratic equation and they will give you some numbers also in front of that equation. Instead of variables, suppose there is x, y, z, t, p, whatever it may be. Instead of those variables, you have to put those numbers, given numbers. If the answer is LHS is equal to RHS, after putting the given values in the given equation, if value of LHS is exactly equal to value of RHS, then the given number is called root of that equation. Once again I am explaining. They will give you equation and they will give you 1, 2, 3, whatever it may be, the values, the numbers. Instead of the variables in that equation, you put those numbers. Instead of variables, you put those given numbers. After putting the numbers and solving, if LHS become exactly equal to RHS, the given number, what number we have put in the equation, is called root of that equation. Simple language. If given number is substituted in that equation, it should show LHS equals to RHS. Given number put in the equation, the LHS must be equal to RHS. Then the number is called the root of that given equation. Let us see the next example. We are starting the next example. Whether the given numbers are roots of the given equation or not. Whether the given numbers are root of given equation or not. Whether the given number is root or not. So, for x equal to 1, LHS is equal to x square plus 4x minus 5. We have taken only LHS. I told you they will give an equation, they will give the number. You have to put the number instead of that variable, and LHS must be equal to RHS. So, for x is equal to 1 is equal to 1 square plus 4 into 1 minus 5 is equal to 1 square 1 plus 4 minus 5. 4 into 1 4 minus 5. 4 into 1 4. So 1 square is 1, 4 into 1 is 1, and minus 5. So 5 minus 5 is equal to 0, is equal to RHS. So for the number 1, when we put x is equal to 1 in the given equation, we got LHS is equal to RHS. This is RHS, this is LHS. We started from LHS, we ended with RHS. So, right there, therefore, 1 is a root of x square plus 4x minus 5. This is the root. LHS equal to RHS. Now, the second part of the example. another number is x equal to minus 1. So for x is equal to minus 1, we will start with LHS. It is x square plus 4x minus 5 is equal to, we have to put minus 1 plus 4 into minus 1 minus 5 is equal to minus 1 square 1 plus minus 4 minus 5 is equal to 1 minus 4 and minus 5 is equal to minus 4 minus 5, 1 minus 9. So answer is minus 8. If you choose correct signs and correct calculations you are doing, you will get minus 8, which is not equal to RHS. Which is not equal to RHS. So minus 1 is not a root of given equation. X square plus 4x minus 5. This way, these examples have to be solved. I request you to try these examples on your own so that you will feel confidence in getting these answers correctly. Sign changing is very important, so be careful while changing the signs. This is the example where the application of the root theory. Just we learned root. Root means LHS is equal to RHS. That root number they are already given, and they have said find one unknown. The value of root they have given. The value of root they have given. And they have said there is one unknown in the equation, you find the value. How? If x is equal to 3 is a root, already they have given one of the root. In quadratic equation you get always two roots. So out of that one is 3. One is 3, and then find if x is equal to 3 is one of the root of the equation, kx square minus 10x plus 3 is equal to 0. Then find the value of k. So how to do? See, already they have given that number 3 is a root of given equation. So instead of that x, we have to put 3. Instead of that x, we have to put 3. Since x is equal to 3 is a root of given equation, therefore put x is equal to 3 in kx square minus 10x plus 3 is equal to 0. Therefore k into bracket 3 the whole square minus 10 into 3 plus 3 is equal to 0. Now 3 square is 9, so it is 9k minus 10 into 3 30 plus 3 is equal to 0. Therefore 9k is equal to, transfer these all constant number to RHS. So it will be plus 3, plus 30 and minus 3. Therefore, you must remember the changing of sign. Again and again I am requesting you to keep in mind changing the sign correctly. So 9k is equal to 27. Therefore, k is equal to 27 upon 9. Therefore, k is equal to 3. This is application of knowledge of roots. When you put the root given by them in the given equation, you will get the unknown, value of unknown. It's very simple. This type of examples I am going to give you guarantee. These type of examples are fixed in board example and school exams. These type of examples are fixed in board exam as well as in school exam. Very nicely you can score the marks. So this is the fifth example of 2.1. Sixth is same one, but in the fill in the blank type. So you try it. So sixth is homework. Sixth example is homework for you. In the next part, we are starting factorization method of solving quadratic equations. Factorization method of solving quadratic equations. So there are total 12 examples. Out of that, 6 I will solve. Alternate 6 I will solve, and 6 you have to solve on your own because it is a practice of 9th standard. It is a practice from 9th standard. Splitting the middle term, and first term into last term. These are two methods we are going to solve in the next part of lecture. Thank you.